Okay, so moving on, so you have apps in physics, you said, and also in chemistry.
That's correct.
Do you have apps in biology as
So
well?
we launched Lab for Physics. In September, we're launching Lab for Chemistry. So you guys are the first one to have a real demo of Lab for Chemistry today.
Right, okay.
And we're working on Lab for Biology and Lab for Science for middle school.
Okay.
So we can
let's
go
do
demo of physics.
Yeah, that would be great.
Awesome. So here we have a Lab for Physics. So as you can see here, I don't know if you can see here in the camera, we've got experiments, different categories of experiments, and we've got different tools. And for us, the participation of female scientists is important. So as you can see in the design, it's very inclusive. I'm going to go to Tools. I'm going to click on Accelerometer. So there's a girl, just like brown girl like me, running an experiment. I'm going to press New Measurement. I'm going to press Go. And you'll see here, I'm not moving my hand, but when I move, you'll see the change in the graph. Can you see the change in the graph?
Yeah.
So this is measuring acceleration versus time in 3 axes. So the smartphones and tablets have different sensors that are normally used for games and navigation, but not for science. So what we do is we use all these sensors to run science experiment. So this was the acceleration measured in 3 axes. This is axis Y. Do we have a volunteer here? I'm going to throw the phone. I'm going to press Go, and you're going to catch it. And when you catch it, you're going to press Stop. Sounds good? Yeah. Okay, I'm going to press Go. Catch it. That's a good catch.
Good
Press Stop. All right, here. So thank you so much. Wow, look at that. So here, when I shaked and threw the phone, you can see, but when the phone, here you go. You can actually see the movement in axis Z, Y, and X. Thank you very much. That was great. So this is Lab for Physics, and we have all the experiments in Lab for Physics. Lab for Chemistry now. With Lab for Chemistry, you can calculate the concentration of a solution based on color. So what we have here is solutions with different concentration, but there is an unknown concentration over here. So here we've got known concentrations, standard concentrations, and what we're going to do with the colorimeter in Lab for Chemistry is we're going to calculate the unknown concentration. So we'll take a picture of solutions with different concentration here. So we've got a standard 1, 2, 3, 4, 5, where we've got known concentrations. 0.2, it's that. I can hear. This is 0.1.
So are you putting in the concentrations you know?
I'm putting in the concentrations that we do know.
Right.
And we are going to then calculate the concentration of the unknown solution. So the colorimeter, for example, normally costs $500, but here, just with an app, you will be able to calculate the concentration of this unknown solution. So here we go. Can you see, can you take a look? Is it visible? Perfect.
Yep.
Yeah. So here, as you can see, I'm selecting the test tubes that we're going to calculate the concentration. So it's going to analyze through pixels RGB in the camera. I'm going to take a picture here. Ready? So here, it selected the area of those test tubes, a blank standard 1, 2, 3, 4, 5, and the one with the unknown concentration. So let's see how our calibration plot came out. Perfect. So here's our calibration plot and the concentration of the unknown solution. That's how simple it is.
Okay. Very cool. So good lessons. So what's next for you?
Everything is so exciting. We at Lab4U, we're very passionate about democratizing science, empowering students and teachers. So you see, good intentions are not enough to solve world's biggest challenges. You need a real understanding to make a difference in the world. So even if speed might be measured by miles per hour, life should be measured as smiles per hour. So if we can bring those smiles to everyone around us, we believe that we can make a difference. And if we think about talent and human capital as an asset, where talent is universal and opportunities are not, we believe that we should give everyone this opportunity to be a change maker and to make a difference in the world.
I love that line, smiles per hour. I've got to remember that. Yeah. So I'm going to open it up now for questions. Anyone from the audience? Yeah, the gentleman there, at the back. Go ahead.
Thank you. I'm a student from China Foreign Affairs University, and I'm interested about the experiment you just showed about the chemistry.
Yes.
So with 5 knowing concentrations of the solutions and the camera, you can calculate the concentration of that unknowing solution. Is that based on the linear regression of the figures of RGP and...
He's smart. He got it. He got it. You got it, my friend. You're hired. Not just... You got it. Yes, indeed. It's linear regression. So as you can see, so it's absorbance versus versus concentration, and the absorbance we calculated with the intensity, and it's RGB. So here it's color pink. So for example, if it would have been color blue or red, the RGB calculation would have been better if we had a complementary color on the back, so that the difference in RGB calculated will give us better precision in the linear regression. So yes, that's it. We interpolate the data in it.
Okay, thank you.
Wow, I'm glad someone was paying attention. That's good, excellent. Good student.